in these community office hours, I want to talk about the Exec module and the various things you can do with it, the little module that could, because it's very flexible and you can use it for a bunch of different use cases. It's basically a great escape hatch when you bump into, say, limitations of Garden. So I'm just going to talk a little bit about the module type. I'm going to start by, doing a little Stackwrap 101. We have some seasoned Garden users on the call, so maybe I can I don't have to spend too much time on it, but it kind of puts the rest, I hope, in context. Then I'll talk about some use cases, then, a bit of story time plus demo. So I had a conversation with a friend of mine the other day. I'm trying to get them to use Garden, and the demo is kind of based on that, and it's hot off the presses. So, there are chances it will fail. There are so many ways for the demo to fail, but we'll see what happens. So Stackwrap 101, you probably know this, but maybe then it's just kind of a refresher. So Garden is built, the Stackwrap rather is built on these 4 action types. That is the build action, the deploy, the test action, and the action for running a task. And these actions can depend on one another. So these kind of 4 primitives, plus the fact that they can depend on one another and be resolved into a graph, that gives Garden all of its powers. And really just if you know this, almost it feels like everything else about Garden kind of just unfolds or opens up naturally. And the way that Garden works then is you describe your stack in terms of these actions, and Garden resolves that and figures out what to do to go from essentially 0 to a running system. So here's the diagram of what that looks like. You have, pieces of YAML to the far left. Ideally, this should be fairly short. It's almost like metadata that you're attaching to the things that are already there. So you have a system, you have code, you have runtime configurations, you have all these things. You tell Garden what they are, where they live, and Garden resolves that into this graph structure. That again allows you to kind of configure once, but you can run it anywhere. So once you've written your initial configuration, you can use that to start up your development environment, to create preview environments as part of your QA process for running tests in CI, and even deploy into production. And one of the benefits of this is that it scales with your stack. And this is kind of important, I think, in the context of the story I'll get into later. Adding new components to your stack when you have a tool like this is fairly trivial, and it doesn't change anything with respect to the workflows of others. It's still just Garden deploy and Garden test. And I guess our hypothesis is that any software system, no matter how complex, can be fully described in terms of these actions and their dependencies. So this comes back to, again, to the story, throw a weird stack at me and let's see if you can fully codify it using these actions, these 4 simple actions, plus defining dependencies between them. But that's not all. The Stackwrap is also pluggable. Garden would be pretty limited in functionality if it wasn't. So what these actions actually do depends on the plugins that you use. So, as a Garden user, the first thing you will do is pick a plugin. So you might go for, say, the Kubernetes plugin, and then those actions have a certain meaning. Deploying essentially, is a kubectl apply. Or if you pick the Terraform plugin, then, deploying or provisioning infrastructure has a different meaning and is executed by Terraform. So that's how it's pluggable, and under the hood, as it were, these plugins implement the handlers that Garden calls. So there's a build handler for your plugins, to deploy service, get service logs, get service statuses, so on and so forth. So Garden figures out the kind of the what and when, deploy a service, give me some logs, but the plugins decide how. And to get to the point, the Exec module or Exec plugin for that particular module type and the particular plugin, the how is basically just executing it. I type bin shell here, but it works across platforms. So, it's also able to execute on Windows, for instance. So it looks something like this. You have your graph, and if you deploy in, say, the development environment, then you're going to use the Kubernetes plugin for that green database action there, deploy the database. It will spin up a Kubernetes pod for your database. If you're using the Terraform plugin, say, in a production environment, it's going to send that context to Terraform, and Terraform will do a Terraform apply and provision infrastructure for you. And if you are using the Exec plugin and say running this in your local environment, it's just gonna basically execute whatever command you pass to it. And this could be on your, this happens on your laptop and or CI runner, as opposed to rather in the cloud. So in general, our philosophy is that you should be developing in production-like environments, and Garden allows you to do that. We often say that there's kind of a trade-off between like, realism and speed of your feedback loop. And we like to think that with Garden, you can do both, or you can have both. Rather, you can develop in production-like environments, still getting instant feedback. But as an escape hatch for those cases where that's not feasible, you always have the Exec module. And that allows you to, for instance, have hybrid environments where like a part of your stack is running locally, often like maybe the web front end and the rest in a remote environment. So it really allows you to mix and match like that. So again, like a little Stackwrap Garden internal refresher before we get into how to actually use the Exec module. So just hopefully put that in context, I suppose, how it works. So with that out the way, we can look at some common use cases. Having explained, kind of how the Stackwrap works, and then by extension, how the Stackwrap can execute like, local actions, as it were, via the Exec module. Let's look at a few use cases. So use case number one, the most obvious one, the one that you're probably familiar with already, is using it to run local scripts. So just like anything that kind of needs to happen locally before, say, you deploy a given service or execute something else. Like in a perfect world, everything is containerized. You just run a Garden deploy and don't have anything really installed on your system. But in the real world, like the fact of the matter is that, often there's something that needs to happen. Some data needs to be prepared or what have you on your local system before Garden is able to kind of, go through the rest of the deployment pipeline. So probably the most common usage of the Exec module type is for those kind of scripts. And as you can see kind of in the code snippet to the left, you want this to be portable, right? So you don't want to like, overfit for, say, a, Linux system, and then you get your first Windows user on team and everything breaks. And you can see in the command section that it checks what platform is being used and then executes the task based on it. I can't guarantee you that this exact syntax works. I can just throw it in there, but it should. And if not, we can help you figure it out. That being said, we're also basically looking to give the user more control over what platform task is executed on. So you could like imagine a field on the task would be like, if on Windows, do this, on Linux, do that. So this is feedback we've gotten before. So what you have in front of you here, it should work, but we want to make it a little bit nicer by kind of allowing you to explicitly say what happens on a given platform by just making it fields on, whether it's the task or the service or what have you. But what you see here is that the Exec module prepares something locally, and then the service is able to reference the outputs from that particular task. It has dependency on it, and it can reference the outputs when it's being deployed. But yeah, hot tip, use templating to ensure it's platform agnostic. Example number two, to store variables. This is probably not as common a use case, but I find it personally super useful. Here's an example. It's kind of taken from our own code base, slightly cleaned up and some things redacted. But basically what we have here is we have an API service. We have a Kubernetes version of it, but we also have kind of just like an API runner module that's used for like running tasks and tests and so on and so forth, that doesn't inherit everything from the Kubernetes version, but rather is a container module and just uses the same image. So there's like a kind of a base image, some Kubernetes module that uses it, and then these runners that also use the same image. But all of them need to share variables. We don't want to like duplicate the configuration across all these module types. Sure, you could throw all of it kind of at the top in your product configuration, but then that gets pretty noisy fairly rapidly. So the idea here is to kind of just use it to store or hold on to variables that then other modules that kind of share the context can reuse. So there's a module called API variables at the top. It defines, for instance, some environment variables, and then the API runner module at the bottom can just reference those directly. And the Kubernetes module, which you need to pass environment variables to Kubernetes of the format like name, the variable's key, and then the value, as you can see in the snippet. So you can then use Garden's template functions to map over these variables and basically return like the key value pairs such that Kubernetes is able to understand them, and you can deploy it as a Kubernetes module. So helpful for grouping variables, keeping your project configuration clean. Example 1.3. So Third one, I think this is another great use case. We've been looking at the Exec module, but there's also a corresponding Exec provider. So, we're talking about Garden plugins. They're kind of split, as it were, into these two parts. There's the provider part of the given plugin, and then the module types that the kind of plugin defines. So here we're using the Exec provider, and not everyone knows this, but providers can actually depend on one another. So in this little config snippet, you can see you have a Kubernetes provider. It has a dependency on the Exec provider, which guarantees that the Exec the Exec provider is basically initialized ahead of the Kubernetes provider. And as part of that initialization, it runs an init script. So, in initializing the Kubernetes provider in the first place, it may need to make some, say, API calls to your cluster. And at that point, you as a user need to be authenticated against your cluster. So having it depend on an Exec provider and giving it an init script is a way for you to do that. And obviously, you don't really want to have whatever access keys you use to authenticate to your cloud provider stored, say, as local variables. So another common use case is to store those as secrets in Garden Cloud. You can scope them to individual users, so everyone has their own set of keys in cloud. And then those are used when basically authenticating as kind of the very first thing that happens before any other Garden action. I think the new thing here, like at least for some users, is that the providers can actually depend on one another. And we really recommend using cloud secrets to store these kind of sensitive values as well. Example number 4 is long-running process. I'll be talking a little bit about this in the actual demo, but this is a fairly new addition to Garden, being able to have Garden manage long-running process. So what I mean by that is like something like, say, starting a dev server. So the command doesn't exit. And usually if you have like an exec task that starts something like that, Garden is not going to wait for it to return. So basically it just looks like Garden is hanging. But since we introduced the dev mode spec to the exec module, you're able to run long-running commands with that as well. But yeah, I mean, there's just some things to point out in terms of the configuration. So you'll notice that for this kind of web local module, the deploy command is empty. So this kind of comes back to why I was like pointing you or like explaining the stack graph a little bit earlier, because as Garden resolves the graph and executes the actions, it's going to want to deploy your local web server, but that's kind of a no auth in this context. So instead, we just leave that empty, and instead it only has a notion of starting the dev server. Like there's deploying a local server doesn't have any meaning, so that's why we leave it empty. But we do include the command to start it when you're in dev mode. So it only runs when you run Garden in watch mode, essentially when Garden is itself in persistent mode. What's useful here, similar to what I showed you before, we're merging in some like common set of environment variables. So let's say like you want to be able to run your web remotely as well. That might be the default, but every now and then you want to run locally and you want to be able to share variables between these, like your container web or Kubernetes web module and then your local exec module. So this is a great way of doing that. And you can overwrite some of these, for instance, at the environment to development. And also of note is that if you're running something locally, there's a good chance that it's going to have other local dependencies, say like a shared library that typically would be built in your Docker container as you deploy it to a remote environment. But right now you need to kind of build it locally. So you can have another local exec module that wraps your library functions. And by setting it as a build dependency, it ensures that that gets built essentially before it then attempts to start the service. So this comes back to kind of the exec module also operates, as it were, within the graph. So it has a notion of a build, it has a notion of a service. And if you deploy the service, it will make sure that the builds which implicitly depend on deploy, that those or like the dependencies of the builds are executed as well. So that's why kind of it's useful to think about the exec module in terms of the stack graph in general, and helps explain why the deploy command say needs to be empty, or why you'd be using builds like this as opposed to all of this could be tasks as well, but this just fits more naturally to the stack graph and how Garden works and how we tend to think about it. So this is basically what we mean when or what we're referring to when we talk about hybrid environments. So parts running locally, parts running remotely. This is how you configure it, and you can stream, for instance, logs as per usual, even for local services. So it's just Garden logs or via stack streams. And now for a little bit of story time. I hope this makes sense to you. But for me, this is really interesting because, again, like, we tend to think about Garden as a tool for working with basically systems that run in the cloud. And that is definitely where it shines. That's our, core use case. But these abstractions, coming back to what I was talking about the Stackwrap in the beginning, our hypothesis is, again, like very much that with these 4 primitives, building, deploying, testing, and running tasks, and their dependencies, you can model any system, whether that system runs in the cloud or on your laptop or in some sort of hybrid fashion. So I was speaking to my friend the other day. He's working at what's I suppose now a decently large company, and they've been seeing some serious growth. Like, just massive scale. They're doing really, really well. So in one sense, that is great. In the other, like, DevOps engineers are swamped. They're doing their best to kind of just, keep the whole thing going. They don't have all the time in the world to maybe think about the developer experience, but they want to though. So the conversation started where he was kind of lamenting just the state of like just starting his workday. And then he's onboarding a new developer to the team and lamenting just the fact that he could barely explain to this new developer how to even get started. So what they need to do is they need to authenticate to the cloud provider, start a tunnel, start local Docker that runs Redis and Postgres as containers, shell into like a separate API repo, and start the server with PyCharm. The reason he uses PyCharm is because that has like a specific Python version set. So if he runs just, Python my app or whatever, it doesn't work. And PyCharm has also like the environment variables just kind of sat in the IDE. And he didn't realize this. He was like kept trying to start it locally. It didn't work because like missing environment variables are only available in PyCharm, not visible to anyone else. This is also the reason why he had a hard time onboarding that new developer. And the API, again, like a SAP repo. So, documentation also just, spread all over the place. He always forgets to init the Git submodules in the API repo. So it's going to go back to step 4 in the submodules and then start the server and then finally start the web server. So he's a front-end web developer and this is what he needs to do to start the day. And very often just like step 3, something breaks along the way. So you kind of need to just start from scratch, or it's never quite sure why it doesn't work. Just sometimes it does, sometimes it doesn't. The point being that none of these steps are kind of codified or automated. It wasn't always like this. Obviously, they started with something simple, but when Bash is your hammer, that's kind of, it's just very hard to maintain. You have a Bash script that's called like, start dev.shell, but then you add like, more parts to your system, and just keeping that script up to date and ensuring that it does all the things for all different use cases is just very, very difficult. Like, Bash is a difficult language in the first place. So the bottom line is that like, they're not working with the right abstractions. The abstractions are building, deploying, testing, running tasks, and their dependencies. That's what you need. Whereas like just an infinite amount of Bash will never get you there. So that got me thinking that like this sounds like a problem that Garden should solve. So I guess the demo is all about answering the question, can Garden help? And kind of walk you through what I did for my friend to help him set up his environment, help him codify the workflows, which he could then eventually, push to GitHub, share with that person that he was helping onboard. So, she could also have the same type of experience. So this is the demo part. For the purposes of the demo, I will have my trusted terminal, the cloud UI, just to kind of be able to visualize the whole thing, and my IDE. And I think I suppose the point here I'm making here is like, so I talked about this 4 common use cases for the Exec module. Another excellent use case is just to model your stack or kind of as a placeholder, as it were. So like when my friend described these 5 or 6 or 7 or whatever they were steps he needed to perform, my first thought was just like, let me just spell it out in Exec modules just to get the graph going, just to be able to visualize it, and then I can take it from there. And then we can gradually place an Exec module by a container or Kubernetes module as kind of progress along. But even just being able to visualize this is a great start. And so I guess what I'm demoing is just my kind of own internal thinking as I was helping my friend get started with this. So I have a project. I kind of added the steps here at the top. You need to authenticate, start database, init submodules, and start the web service eventually. And note that the API is like is in a different repo as well. It's called vote demo because we're always demoing the vote demo project. So don't mind that. And here are just some like basic variables you might need as you're getting started. So, API port, you notice like the host names, they're all local hosts because we'll be running everything locally. Not really using a lot of templating now, just to get started. And then I just have a single provider. It's the Exec provider, and it has this init script, which ensures that it's the kind of the first step here. We want to be able to authenticate before getting started. So the Exec provider ensures that via that script. And the next thing is to just start the database. Again, like we don't have a Kubernetes cluster. We can't just add a container that uses the Postgres image and get started. But we have Postgres installed. I have Postgres installed on my laptop. So just in the spirit of really getting started with this, we can just add a local Exec module that starts Postgres like so. So just called DP local. It's only enabled for the local environment. We'll get to that later. And it runs as a service. So it starts the Postgres process as you can run a garden and then just kills it again once you're done. Don't worry too much about this ugly task here. It's just for initializing it with the data that the application works. And the way it starts is just, we just really like run the Postgres command. And again, in different platforms, we can use templating to, might be useful to wrap this in a script that can then, execute properly depending on the platform. Already, we should be able to, fingers crossed, do something like garden dev. I'm running force refresh just to ensure that the auth script runs every time. But let's see. Yes, it is running the auth script. As you can tell, it's connecting to the cloud provider. It's establishing the tunnel, and it's finished authenticating. To be honest, that script only echoes out these things. It doesn't connect to anything. But that's again a good, it's a good placeholder as you get started, and then you fill in the details. And coming here, I'm gonna pick my namespace, and sure enough, I can already start understanding kind of, okay, this is what my stack looks like. I can already visualize, I suppose, the steps needed to get started. I can also run the logs command. Even though it's running locally. So it starts, displaying logs from Postgres, and then basically again, kind of, repeating my line of, or like kind of train of thought or whatever, like my way of thinking about this as I was helping my friend get started. I just kind of added, one module at a time. So I just ran garden dev mode so it can pick up changes as I make them. You can see it's kind of, rerunning some things here due to the changes to kind of the project configuration file. And so what I did here, I just added a local version of the API. And what that does is it has a task for initializing the submodules, which, doesn't really do anything either. Again, we're not trying to keep things fairly simple here. But you'll also notice that it's not actually a part of this code base. So this is a remote source. And just like for my friend, he had the remote source on his laptop, so I'm just using the direct file path. But more generally, you would pull this from GitHub and have the actual like Git URL for this thing. The command runs python3 app.py, and looking at my logs, I would expect maybe it doesn't log anything right away. But looking at the Stackwrap though, you can see already. Okay, so there's the API. So what needs to happen is I build a database, build API. It has dependency on the database being initialized, so on and so forth, and gradually just add all the parts of the stack. The last one being the web part. Basically, the end result here is that my friend is going from like having to follow the all these steps, things constantly breaking along the way, everything like nothing documented really, or whatever is documented, there's different repos, and onboarding new people is pain, to kind of having everything codified and automated. So at this point, the web server is live as well, and so now starting the day is literally just, see, it's gone from like just a handful of scripts shelling into things, initializing submodules, turning on Docker, what have you, to just running this single command. I can stream the logs from all the services as things are running. And I'm pretty sure that if I now go to a local host 8080, where the web is running, yes. So the application is running, everything is local. The front end is talking to a local Python server that the Garden is also managing, which is talking to a local Postgres instance, which Garden is also managing. But the main point is that I can run all of these things from a single command. And I think, yeah, even voting works. So let me see. I would expect to see the logs from the services. Kind of wondering what that's about. Like I told you, this demo was all very last minute. So let's see. Just run the command with good measure. So maybe the logs are turned. Oh, there you go. So we have the logs from the web server, the API local server, and it actually works. It doesn't update for some reason, but I can vote and I can run the application. And the point is, I can run the application in a single command, and it's codified, and I can visualize it, and I can share it with the rest of my team. So like no more brittle workflows. And another benefit, so I was talking about kind of the Exec module as a way to kind of model things. So if you're getting started with a new project, a big project, there's a lot of things, a lot of dependencies to untangle. Often it's useful to just, throw it all into Exec module, just have them, run echo okay or whatever, just to figure out kind of what the shape of the thing is, and then gradually basically replace these with the real thing. So going from this, I'm going to add another environment here called hybrid. So let's just do like this. Very similar to the one from before, but you notice that like these look a little bit more like real world. So it has actual host names and so on and so forth. And obviously, like this is not going to work unless we are able to deploy it somewhere. So I'm going to throw in a Kubernetes provider for good measure. So again, for most users, this is something that they can then gradually introduce. You have Garden already as a way to just get started super rapidly, model your stack, and then you can take steps towards your remote environment if you don't have the time or the resources, what have you, to do that right away. So now we have a Kubernetes provider. I just kind of copied the config in, and as a final step, I'm gonna enable the config. I'm not gonna bore you with all the details, so I'm just gonna container module config. I'm just gonna move it to, hope this will work. Container module.ground.yaml. I just kind of disable them like this. I'm gonna restart this process for good measure. Oops, no, that was the whole thing. So I'm gonna run this again, current dev, but now in the hybrid environment. So what should happen is that we're still deploying parts of the stack locally, in particular the web service, but because we found the time, or maybe let's imagine there's an office hackathon, and someone used the chance to finally containerize that API module and get a development Kubernetes cluster, and now now they have that, they have the Docker file, they have the configuration, they have the cluster. So it's trivial to really just disable the local module, which should be here. Oops. And enable the other one. So you see already, like, it's disabled if the environment name isn't local. And let me see, I'm just gonna change the dependencies here. It's one thing I forgot. So now I'm looking at the web local. I'm gonna have it depend on the real API. And that should be, just for comparison, that's here. It's very similar, except now this one is disabled if the environment's not hybrid. So we use the real thing, the container, in the hybrid environment, otherwise just the local version. So let me just see one more time if it deploys that one. So you should see that, of course, like, it's complaining about a few things. Again, this was quite hurried, but you should see that the proxy, so the proxy for this one points to the remote version. So coming back to the configuration, I think one of the, at least big benefits of this approach is that I was saying that, like, previously my friend had all these environment variables like in PyCharm, and he didn't even know that. He had no idea why it worked in the first place. That's something that some other person set up for him. And every time, like, he, I don't know, like, messed around with ports or whatever, just everything would break, and he had no idea why. So here, just making it super explicit, and we're reusing and sharing it across like different modules, different services. If it's local, this is the API port. If it's remote, this is the port. And then that gets fed to the actual services at some point. Scrolling down here. Yeah, so you'll notice that this is the API local service. It has this environment. It has a Postgres database, Postgres password, so on and so forth. These values resolve to like localhost in your local environment, and they resolve to Postgres or whatever in your real environment. But in the actual code, there are no if statements. It's just DB hostman. It's just DB hostname is just read from the environment there. So I think this is another huge benefit. Like you're just declaring things up front, and then Garden's figuring out what actual values at runtime it injects, as it were, into the services. So coming back here, you can see that it is the API. Sorry, the front end is now actually speaking to the remote API. And I think that if I refresh, yes, so I refresh and you see that it gets, a different data set, because that's the data set from the remote database. Don't ask me to vote, because it does work. I haven't, that was the final piece of the puzzle. I didn't have time to set that up. But otherwise, whether these services are local or remote, you're streaming logs from them, and it's still just a single command. And then some person responsible for DevEx on your team can set this up, and everyone else can benefit, those currently working and future employees. And that about wraps up the demo. That's all I wanted to show you. Thank you so much for listening. And with that, if you have any questions, I'll be happy to take them now.